So predicting the products of dissolution is basically testing you on whether you remember the difference between ionic compounds and molecular compounds. So remember, ionic compounds tend to be metal and non-metal. Okay, occasionally there's some funny ones like ammonium carbonate or something, in which case the metal is the ammonium ion, which is composed of non-metals, right? But generally, if you see metal and non-metal, that's ionic. Ionic completely dissolves, breaks apart, completely breaks apart into ions if soluble. Okay, but I'm not going to expect you to differentiate that yet. Okay, in aqueous solution, aka water. Okay, if it's molecular, okay, that means it's all non-metals. Okay, and the individual molecules will move apart from each other, but they're still stuck together as molecules. There's no charged particles. Okay, so molecules remain intact in solution. Okay, so no charges ever, no breaking apart. Okay, so if we look at all three of these, there's all carbons and oxygens and hydrogens. I would say those would all be molecular. Okay, so how you'd write a dissolved molecular thing like acetonitrile, you'd write the formula CH3CN and then AQ, okay, to say that it's dissolved. It does not break apart into ions. And of course, the other major species is water, right, because it's dissolved in water. So that's the same for any molecular compound. So these, all three of them are molecular, okay? Molecular, molecular, molecular. So the acetone would be CH3, 2CO, AQ, and there would also be water. Yes, I do believe you need state symbols. You might be able to get away without putting state symbols for the water, but definitely the molecular species, you would need the state symbols. Okay, so there is always water there too. All right, let's see what's on the next one and see if we can find anything ionic. Okay, because when we have something ionic, we have to actually work out what ions we have. Okay, so in this case, we've got two ionic compounds, which is sodium carbonate and the nickel 2 bromide. Okay, so the sodium carbonate is going to break apart. If it helps, write an equation. Okay, so that molecular species doesn't really exist, right? We discussed this when we were talking about balancing molecular equations for aqueous reactions. That's not really a thing, right? So it's going to break apart into the sodium cation, and for the stoichiometry, there's two of them, right? And then we have the carbonate ion CO3 2 minus. Okay, so it really is important to know your common polyatomic ion charges and stuff by now. Now, I don't think you need to give stoichiometry to answer the question. You can just say Na plus AQ, CO3 2 minus AQ, and of course there is water. Okay, the important thing is identifying what is ionic, what is molecular. Okay, so this nickel 2 bromide, NiBr2. Nickel's a transition metal, so it has variable charge. You'll have to work out the charge of the nickel based on the fact that we know bromine is Br minus. And there's two of them, so the nickel must be nickel 2 plus in this case. Okay, so with transition metals, you have to just kind of work it out from looking at what it's bonded to. So nickel 2 plus, AQ, of course, bromide, Br minus AQ, and of course there is water in there as well. Okay, and then the isopropanol is molecular, so it's not going to break apart. It's just going to stick together, C3H8O, AQ, and of course there is water. Okay, let's just look at one more, see if there's any kind of funky ionic things. MgSO4, you got to remember the sulfate ion is SO4 2 minus, so that'd be Mg2 plus AQ, SO4 2 minus AQ, and of course water. The other two, the isopropanol and the sucrose, those are both molecular, so they don't break apart. You just write like C12, H22O11, AQ, like that. It does not break apart. Okay then, have some fun with that. And just, if you're not good with your ionic compounds, writing the formula of ionic compounds, breaking them apart into ions, this is the time when you really do have to know it, like for real life.